Okay, so I just wanted to show you one more problem, one more example of one of these proofs that's a little bit trickier than some of the others, and just so you get a little bit more experience. So here's something that we actually proved in the previous lecture. And here's a summary of our proof. And I'm just showing you this to remind you of the structure of these proofs, right? So if we are proving that the left-hand side equals the right-hand side, then boy oh boy, at the top or the bottom we better have one of each, right? And if you look down here at the bottom, I have the right-hand side. Up here I start with the left-hand side, and every single step along the way I justify with one of the properties of regular expressions. So let's do a somewhat more complicated problem, I think. Let's prove that this is the same as that, right? That these two regular expressions are equivalent. So what I'm going to do is I actually kind of pre-circled some of these pieces so that you can see what I'm doing with my proof. So I'm starting with this expression up here on the left, and I'm working towards the expression on the right, right? And so, of course, the first line that I put in here was the same as the expression on the left. Here's my next step. And what I've done is to try and show you which piece is R, which piece is S, and so on. I've just circled them. So what I've got here is up at the top I have R plus S star, right? So that really tells us that this A is R and that's S. And we can see that that is in fact equivalent to, by the closure 7 rule, that's equivalent to R star S, quantity starred, R star whatever, but you can see that there's our R star S, and we star the whole thing, and then we have R star, right? So we left the stuff outside the parentheses the same, and we used closure 7 rule to do that first step. Now what I've done here is I've just erased the circles. So that's what it looks like if you don't have circles, because of course in a real proof you don't circle things in fancy colors. So here's my next step with circles. So I'm showing you how did you make that leap, and the reason is closure 8. And in this particular proof, you don't have to do this in your proofs, though it may help you. I've said, what is closure 8, right? What is the piece that I'm using here that tells me what's going on, right? And again, you can see that the expression R is just the single symbol A, and A star BB star is my S, so that gives me that RSR star is the same as RS star R. So by closure 8 we can make that step. Again, same thing we had before, I just got rid of the circles. Now I'm showing you how I did this step. I say that I did this step between these two by using this rule, and I've just stuck the circles in here again so you can see what's going on. So we've got our B is now our R, and this whole green stuff is our S. And there's our R again, so you can see we have something of the form R star, and then the parentheses, and we have S R star star, and we just change that to R plus S quantity starred, just like the closure 7 rule says we can do. And whoa, look, did you notice? We actually got what we were looking for. So we get to write QED. I am done my proof. I have proven what I intended to prove. Yay.